So hello everyone, welcome to lecture number 15A. We are going to discuss today about performance parameters of single phase semi converter. Now we are considering RL or RLE load, and we are also assuming that we have a continuous load current. So under these circumstances, let us proceed ahead. So far we have observed that even though the AC input supply is purely sinusoid, the input source current or the output load voltage and the output load current are complex waveforms. That means it contains harmonics. So let's look at it. So this is my output, load current, which is not at all constant. This is my output voltage, which is not at all sinusoidal, no longer sinusoidal, and this is my input source current, right? Which should have been a sinusoid, but it's not a sinusoid. तो sinusoid नहीं है मतलब क्या है? It contains harmonics, right? So we have to analyze these waveforms by applying Fourier series. You know what is a Fourier series, right? So we'll be analyzing it. So what happens is the current at the AC input terminal of a semi-converter consists of fundamental component superimposed with harmonics. So this is what happens actually. So therefore, depending upon the load current waveforms, there is a phase difference. देखो, this dotted line is my input. So current or voltage same phase में चालू होने चाहिए, right? But there is a phase difference. We are delaying the start of a SCR. So SCR starts after alpha. We know what is alpha, right? What is alpha? Firing angle. But because of this delay, there is a lot of harmonics and there is a phase difference between input and input voltage and input source current also. Okay, so we'll analyze that, and that's why your input power factor is different. Therefore, it becomes very necessary to analyze or define the external performance parameters of semi-converter. Now, यहाँ पे external performance मतलब input and output performance parameters of semi-converter, right? So, performance parameters of a semiconductor are derived from their input and output waveforms. Okay? There is one assumption over here. That assumption is that the input or the output current is assumed to be continuous, discontinuous, right? During this derivations. So I've written a note also. These following derivations are not there in your syllabus. Only the end result and the expressions will be utilized further. So let's quickly start. This is just pure mathematics. Under steady state condition, the output voltage of a full converter actually, it should have been a full of a semi converter is generally a periodic function of time. Yes, is it a periodic function of time, right? What do you mean by periodic? The one which repeats itself after a period of t. Same nature, right? So V out of t is equal to V out of t plus capital T, where capital T is a periodic function. Now, if I consider f as the frequency in hertz, then the angular frequency will be 2 pi by t, capital T, or 2 pi f. Omega is equal to 2 pi f, you all know. So that can be rewritten in the frequency domain. V out of omega t is equal to V out of omega t plus 2 pi, where 2 pi is the period. 2 pi क्यों है? Because 2 pi is the period of one cycle, input cycle. Now, this V out of T is the output voltage of a semiconductor which contains harmonics. That means it is not purely sinusoid but periodic है. Sinusoid नहीं है, but they are periodic, right? So we break V out of omega t using Fourier series. So we'll now use Fourier series. We know what is Fourier series, right? Just to recollect, it states that a periodic function can be described by a constant term, which is a DC component, plus an infinite series of sine and cosine terms. Sine and cosine terms are harmonic, right? Of frequency n omega, where n is first, n can be 1, 2, 3, 4, right? So this is what it is. Equation number 4 is my Fourier series. So V out of t can be written as A0, which is a DC component. Now तुम्हारे output में DC component क्या है? Average output component. V out average, or we also call it VDC. Now this is a summation sign. That means you add all these terms. So it will be an cos n omega t plus bn sin n omega t. I guess you have learned this thing in mathematics somewhere, Fourier series, right? So this is my DC component. This is my harmonics. So we have to analyze this to understand why does the waveform, the waveform which are not in periodic sinusoidal nature, they are contain harmonic. Which harmonics are affected? Okay. So here we have described that A0 is the average value of the output. So A0 is described in the following manner. right? In frequency domain, it's written as a period is 2 pi. So integral 0 to 2 pi V out of omega t d omega t, equation number 5. Then an and bn are defined as follows. An and bn are constants. You might be knowing that, right? So they are defined in this manner. 1 upon t, 0 to t, V out of t, cos n omega t, d omega t. Now my question is, why it is written 1 upon pi? It's actually not written 1 upon pi. Are you understanding? It's 2 upon 2 pi. So that becomes 1 upon pi actually. So that is 0 to 2 pi V out omega t into cos n omega t. Equation number 6. Similarly, in equation number 7, Bn we have sin n omega t. These are standard definitions, mathematics. Remember, A0, Bn and An are constants. Now, if V out is discontinuous, V out discontinuous है क्या? What do you mean by discontinuous? ये V out है ना हमारा for a semi converter. Something goes to zero, it's discontinuous. So V out is going to zero. That means ये discontinuous है. It's periodic. It's not a sinusoid. Neither is continuous. It's just continuous. या ये waveform में continuous क्या है? I out is continuous. That is the assumption, right? But V out is not discontinuous. So if V out is not discontinuous, several integrations over the whole period must be performed to determine the constant A0, An and Bn because it is continuous here. So what we do is we add An cos n omega t, Bn sin n omega t. Are you following? Right? So I'll just give you a simple example. Let's say this triangle. Can you see this triangle? Hypotenuse theorem पढ़ा है ना? An square plus Bn square is equal to Cn square. So यही है. An plus Bn is equal to An square plus Bn square raised to half. कैसे आया ये? You have how can I write An? I can write An as An square raised to half. लिख सकता हूँ ना ऐसे? तो यही किया हुआ है यहाँ पे. Same thing has been done over here. And we know the definitions of the angles. If this is a square, b square, c square, what is c square? A square plus b square, right? And what is sine phi n? If this is phi n, then what is sine phi f? An upon hypotenuse. Cos phi n is bn upon, तुम लोग ने ये सीखा रहेगा when you study trigonometry. Sin theta, cos theta, tan theta. Right? These are the definitions. So sin phi n is an upon an square plus bn square raised to half. यही है from this triangle. And cos phi n is bn upon an square plus bn square raised to half. Okay, so those are the terms which we have utilized over here. So yeah, we got equation number 8. You add those two terms together and we get this equation number 8. Now here we have defined phi n, which is the angle, right, of phi n, and whose adjacent side is bn and opposite side is an, and hypotenuse is an square plus bn square raised to half. And what is phi n? Tan inverse of an upon bn. Tan inverse of an upon bn. So this is very, very important. Now from equation number 8, what is an upon an square plus bn square raised to half? Sin phi n. That is what we have written. Sin phi n into cos n omega t. And what is bn upon square root of an square plus bn square? Cos phi n. So here we have written cos phi n. Now here there is a term sin a cos b plus cos a sin b. So it will be sin of a plus b. Right? Again another trigonometric relation. So an cos n omega t plus bn sin n omega t is equal to equation number 10. Just an square plus bn square raised to half into sin n omega t plus phi n. So we rewrite that equation number 4. What is equation number 4? This. We rewrite this equation number 4 and replace this entire term with this. See, that's what we have done. Right? So we replace this with this, and now we call Cn as an square plus bn square raised to half. So your final form becomes like this. V out of t is equal to A0. A0 is the DC component plus summation of n going from 1 to infinity. Cn sin n omega t plus phi n, where phi n is tan inverse of bn an upon bn. This is equation number 12. All these things I have discussed before, but I am repeating it again. where Cn and phi n are the peak magnitude and the delay angle of the nth harmonic component. N stands for nth harmonic component of the output voltage. Now, one more thing is there, one more concept is there. In a waveform of half symmetry, what do you mean by half symmetry? मतलब एक पीरियड में there is a positive half cycle, negative half cycle. So in that positive and negative also they are also symmetric. So उसको बोलते हैं half symmetric. What do you mean by full symmetric? Entire period is symmetric. So our waveforms of a semi-converter are half symmetric. So the negative half wave is a mirror image of a positive half wave. नीचे मिलना चाहिए ना, हम लोग ऊपर ही मिलता है, full wave rectifier. So that is what half symmetry means. So in short, advantage is सारे के सारे even harmonics चले जाएंगे. If it is a half symmetry, only hard harmonics will remain. मतलब n cannot be 2, 4, 6. N can be only 1, 3, 5. What is one fundamental component? 3, third harmonic component. Fifth harmonic component. Right? So due to half symmetry, also the average value of the output, A0 is 0. This I will come back to you when we derive for semi-converter. I'll come back to this point. So your equation gets simplified to this now, that A0 term also disappeared, and now you have this summation of n equal to 1, 3, 5 up to infinity Cn sin n omega t plus phi n. So whatever we discuss from now on, this will be the basis of it. Are you following? Now, till here, equation number 13, nothing is there in your syllabus. From now on, where I write single phase semiconductor with RL load, everything is there in your syllabus. So what are we going to analyze? We are going to analyze this waveform. What is this? This is my input source current waveform, which is not at all, it is a periodic waveform, not at all sinusoid. It contains harmonics. That's why we are analyzing this waveform using Fourier series. Are you getting it? Right? So here one more thing is there. From 0 to alpha, my source current is 0. And from pi plus alpha to 2 pi plus alpha, again my source current is 0. So I can define my period also. And from alpha to pi plus alpha and pi plus alpha to 2 pi plus alpha, the current is continuous but not constant. The current is continuous but not constant. Why it is continuous? Because load current is continuous. Agar load current constant रहता, to this also would have been a constant. Okay. So here we assume that your IS is assumed to be ripple free, and the peak amplitude during each period, this is I naught. This is I naught. And this is minus I naught. This is the peak amplitude. So what is this peak amplitude? I out average. I out average is fixed, right? So I out average is written as IO or I0. It's also written as IDC. Write down somewhere. These terms will come together. So I out average is equal to I0 is equal to IDC, which is a constant load current. And write down this equation number A. Quickly write down equation number A. In of t is I0 plus summation of n equal to 1, 2, 3 up to infinity Cn sin n omega t plus phi n, where Cn is an square plus bn square raised to half, phi n is tan inverse of an by bn. Now I need not explain that. I already know. So quickly write it down. Write up till equation number A. Cn and phi n and In of t expression. Written? Now listen, don't write anything now. Next. Now we told you earlier I0, earlier V0 was 0. Now here why I0 is 0 we will prove now. So 1 upon 2 pi. Now what is the assumption over here? What is the assumption? Constant load current. What do you mean by constant load current? इसका मीनिंग होता है कांस्टेंट लोड करंट, राइट? दिस इज द मीनिंग ऑफ आई आउट, और ये वैल्यू आई ओ है. नाउ वेदर अल्फा है या तो फिर पाई है या it is pi plus alpha, it doesn't matter, it's constant. बराबर है? So we defined a period from we defined a period from alpha to pi and then pi plus alpha to 2 pi. यही period क्यों? Because between 0 to alpha and pi plus alpha to 2 pi to 2 pi plus alpha, your input source current is 0. मतलब वो constant. नहीं, या आउटपुट वोल्टेज इज 0. आउटपुट वोल्टेज इज 0. हाँ, now it is okay. Not visible. Okay. Not now. What happened suddenly? Suddenly it happened. Okay. Can I continue? Okay. Yeah, what I was saying was during this period alpha to pi and pi plus alpha to 2 pi, I0 is constant. So we can take it out. बराबर ना? मतलब it's a constant value. It's basically I0 is basically constant throughout. Actually इसको 1 लिखना चाहिए था. I0 ठीक है, fine. So from here we can determine, actually इधर I0 आना चाहिए था. Anyways, so here this will be omega t pi alpha to pi and this will be pi plus alpha to 2 pi. If you see carefully, all the terms are cancelling out. That means my I0 becomes 0. So that's why that constant average value was, this A0 in the previous case, and here it is I0 is 0. Constant value. Fine. Then an also can be defined in the same period, and this derivation is not there for you all. Write down I0 is equal to 0 in that harmonical expression. And then an is equal to minus 2 I naught divided by n pi into sine n omega t into sine n alpha, where n is 135. If you solve this, you will get this. It's not expected that much. So write down an, and if you solve this further for even values of n, the term will come out to be 0. An will be 0, and that proves the point it's half symmetry. Even harmonics are absent. Okay? So you have to write an minus 2 I naught upon n pi into sine n alpha. Similarly, write down bn value. 2 I naught upon n pi into 1 plus cos n alpha, where n is going from 1, 3, 5. Okay? You all only write something which will be useful to us in our numericals. Then Cn. Now, an and bn square, it's a constant, right? We have determined them just now. Correct? So here I am not doing the derivation in detail, but still 1 plus cos n alpha, right? It is same as 1 plus cos n theta, which will be twice cos square n theta by 2. ऐसे होता है उसका expression, right? So in this case, this is what you will get. So write down C and this expression. 4 I naught upon n pi cos n alpha by 2. Cn is 4 I naught n pi into cos n alpha by 2. लिखा है Cn? Now phi n, write down phi n. Now listen, an and bn we have determined, right? We are just dividing it. So क्या है हम लोग को sin n alpha divided by 1 plus cos n alpha. And what is cos n alpha? 2 cos square n alpha by 2. And what is sine n alpha? Sine n alpha by 2 into cos n alpha by 2. This is just trigonometric ratios. So from here, eventually you get phi n as n alpha by 2. So write down this. You all don't have this all, huh? Derivation जिसके नहीं है, खाली final expressions है. And what is phi n? Phi n is the displacement angle of the nth harmonic current component. ठीक है? लिखाइए phi n is n alpha by 2. Now rewrite the final expression. ये वापस लिखो. I in of t is equal to summation of n is equal to 1, 3, 5. Only odd harmonics going till infinity. This is your value of Cn. ये Cn है. So 4 I naught upon n pi into cos n alpha by 2 into sine n omega t plus phi n thana. And what is phi n? Minus n alpha by 2. So this is very, very important. This will define your sinusoid nature. I mean that source current, the wave shape nature. This will define that. Okay. Now write down the RMS value of the nth harmonic input current. The RMS value of the nth harmonic input current. What is RMS value? When a peak value is given, how you determine RMS? Peak divided by root 2. Barabar na? So what is this? This is as good as Cn, right? This is your, maybe we can call it as a peak value of current. Either. So this divided by root 2. So yahi likhna hai. Entirely you have to write this only, divide by root 2 just. That's it. Are you following what I'm saying? This Cn which is written now, you have to write the same thing from here, divide by root 2. That will be your In of n. That is RMS value of the nth harmonic term. So write down In of n is 2 root 2 I naught divided by n pi into cos n alpha by 2. Equation number C. What happened? Now it has come. लिखा है? You have written. Now write down what is phi. देखो, सुनो, ध्यान से सुनो everyone. If In of n is 2 root 2 I naught divided by n pi cos n alpha by 2. First fundamental component क्या होगा करंट का? n की जगह 1 substitute करो. So In of 1 will be 2 root 2 upon pi I naught cos alpha by 2. समझ में आया? First fundamental component. Third harmonic क्या रहेगा? n की जगह 3 लिखो. Write down what is phi 1, displacement angle between the fundamental component of the supply voltage. It's minus alpha by 2. So this negative sign will show that your fundamental input current is lagging behind the source voltage. And what is this actually? Phi 1 is nothing but your firing angle most cases. In this case it is minus alpha by 2. You have written what is phi 1 and In of 1. Now RMS value, ये सारे RMS value का fundamental, RMS value of the fundamental current. ये हम लोगों ने लिखा है ना पहले, In of 1, ये same है. This is same. Then the RMS value, सुनो, next. RMS value of the total input current. All the harmonics सब मिला के, we have to determine like this. In of n, हमारे पास expression है. Sum it up between one, this infinite series raised to half, or else you can directly determine from here also. ये सब लिखो मत, but so we have to find out In of RMS. So I am directly showing you the end result. You can do this on your own and you can find out. It happens in this manner only. RMS कैसे निकालते हो? 1 upon t, 0 to t, then that inside term is there, that square dt. तो वैसे ही किया हुआ है. Same way it has been done. एंड रिजल्ट ये लिखो, RMS value of the total input current is this. What is I naught? I naught, ion is IDC. See, there is a confusion. ये मैं बताता हूँ क्यों आता है. पाई माइनस अल्फा अपॉन पाई रेस टू हाफ, ये लिखा. देखो हम लोग बोल रहे हैं यहाँ पे ए एन जीरो है, राइट, बट here I have used the same term for this. So actually इसको हम लोग when we write this ना, this can be written as an also, no problem ना, a0 जरूरी नहीं ऐसे वही है. This also can be written as this a0 only. वो कंफ्यूजन नहीं रहेगा. तुमने बोलो कि I0 to IDC है तो वो जीरो कैसे है? जीरो नहीं है. This is a constant. We can write here a0. ठीक है? Fine. And now there is no confusion, right? Okay. From till where you have written? Till here you have written, right? Now write down performance parameters of semi converter. First is displacement factor. Definition मत लिखो, खाली expressions लिखो quickly. Displacement factor. Now look here. First let me explain and then you can write the expression directly. देखो इधर. Everyone look here on the slide. So can you see this waveform? In this waveform, the blue one is my input line voltage, RMS voltage. वही, हाँ, line voltage. My dotted line is my fundamental current, IN of 1, जो expression हम लोग ने find out किया है. It should be sinusoid. पर हमें मिल क्या रहा है? We are getting a almost like a square wave, which is your fundamental current. IN of 1. I mean, this is my fundamental current, but this line, green color one, is my actual source current which I am getting when I apply it to a converter. जब मैं converter को देता हूँ ऐसे मिल रहा है. Actually ना ऐसे नहीं मिलता है. You will get ripple also. ये देखो. Somewhere it is there. Let me show it to you. हाँ देखो. What is this? If this is, what do you mean by ripple here? That means the waveform will be like this. बराबर ना, ऐसे ही हुआ ना, फ्रॉम अल्फा टू लेट्स से पाई प्लस अल्फा एंड ये 2 पाई प्लस अल्फा. अगर रिपल नहीं है तो ऐसे दिखेगा, स्ट्रेट, ऑलमोस्ट कांस्टेंट. करेक्ट. दिस इज अज्यूमिंग दैट योर लोड करंट इज ऑलमोस्ट अ स्ट्रेट लाइन, बट हमारा लोड करंट भी स्ट्रेट नहीं है. वी आर अज्यूमिंग इट इज स्लाइट वेरिएशन बट कंटिन्यूअस. सो दिस इज व्हाट आई हैव ड्रॉन दैट ग्रीन कलर कर्व. ये देखो, the green color curve is just that only. Are you following? This is what my actual IN is. So now, what is the phase difference between V in and I in? Phi, na? So this phi is called as displacement angle. This phi is called as displacement angle, and that cos of phi is called as displacement factor. So write down. ये पूछ सकते हैं, what is displacement factor? Explain. So displacement factor is if phi is the angle between the fundamental component of the input current and voltage, then displacement factor dF is cos of phi 1. Actually phi 1 लिखना चाहिए. And what is phi 1? Minus alpha by 2. तुम लोग ने phi n क्या लिखा है फॉर्मूला में? phi n minus n alpha by 2 ना. तो जब भी n 1 है तो क्या होगा? minus alpha by 2. And you know what is cos of minus? Cos of, if there is cos of minus 60, it is same as cos of 60. So displacement factor for a semi converter is cos of alpha by 2. लिखा? ठीक है? Now there is an alternate definition, but we are not going in details of this. We are going next. Write down input current distortion factor. Current is distorted, right? So we have to calculate that factor. Input current distortion factor. Write down. Its short form is CDF. Write down the main formula, I in of 1 divided by I in RMS. I in of 1 divided by I in RMS. Don't write this complex equation. Huh? See, here remember mat karo. What is there inside the box? You know the individual expression of I in of 1. You know the individual expression of I in of RMS. वो remember करो. This is just a division. अगर ये remember करने जाओगे तो पक्का mistake होगा. So what you write CDF is I in of 1 divided by I in RMS. Don't remember. Don't write anything else. वो derive कर सकते हो. That is very easy if you remember that. Now write down input power factor. What you will write input power factor? CDF into DF. What is DF? Displacement factor. CDF is the current distortion factor. इतना ही formula लिखो, आगे मत लिखो. Though who will remember this formula? You know what is CDF? Previous step में calculate किया है. You know what is DF? Cos alpha by 2. So just multiply them to get power factor. समझ में आ रही है बात? Don't remember that complex expression, even though I have written there. In the exam, if they ask you to derive these things, then you derive, na? In numericals, if they tell you to calculate, don't remember this formula. Next, harmonic factor. Or it is called as total harmonic distortion. Write down both. Harmonic factor or total harmonic distortion. HF or THD. You know which formula you will write? This one. Which I have taken down. HF is 1 upon CDF square minus 1 raised to half. So CDF you have calculated from previous step. No need to remember this complex thing. Unless they ask you in the theory. और ये सब है हाँ, these all are there. They might ask you, derive this, the what do you mean by harmonic factor and derive the expression for it. तो ऐसे ही expression derive करना है. For full converter or semi converter. Then you have to write all these things which I am writing. But for numericals, you just remember that basic formula. Okay? Next, voltage ripple factor. Which formula you will remember? It's form factor square minus 1 raised to half. Voltage ripple factor is called as RF. It is square root of form factor square minus 1. And what is form factor? V out RMS upon VDC. Form factor for a semi converter is V out RMS upon VDC. Now we have studied single phase, full wave control rectifier, or actually we can write this over here, one phase semi converter. So one phase semi converter के लिए you have derived it. V out average is coming out to be which is same as VDC, Vm upon pi 1 plus cos alpha. लिखना है तो लिखो, नहीं तो ये derive किया हुआ है हम लोग ने. Then V out RMS, it's Vm into pi minus alpha upon 2 pi plus sine 2 alpha upon 4 pi. We have derived this many times, raised to half. So यहाँ से V out RMS calculate करने का, divide by VDC and then calculate form factor. Once you calculate form factor, substitute in this formula, then calculate ripple factor. So you have written these formulas. Okay. Don't write this complex thing. Then write down output DC power P out or PDC. It's V out average into I out average. Then output AC power, that is V out RMS into I out RMS. Okay. V out RMS into I out RMS. Then rectification efficiency is PDC upon PAC into 100. Rectification efficiency is output DC power upon output AC power, which is PDC upon PDC upon PAC into 100. Written down. Come on, fast. Completed? Next is active power input, PI. तुम लोग ने यह heard of a power triangle, active power, reactive power, apparent power. There is a power triangle, right? So ये वहां से आ रहा है. Anything reactive is waste, active is useful, apparent is useful. Okay, so write down this formula. Pi is RMS. I mean, let me just explain. RMS value of the source voltage, which is V in RMS. RMS fundamental component of source current, which is In of 1, and displacement factor, which is cos of alpha by 2. अभी ये इतना ही फॉर्मूला लिखो, डोंट डू दिस, ये रिमेंबर मत करो. रिमेंबर In of 1 expression, V in RMS, then DF. So write down what I have written in the box. Pi is V in RMS into In of 1 into displacement factor. Clear it is? So write down this also. Pi is coming out to be VDC into IDC. पूरा डिराइव होके ये मिलता है, ये इजी है इसीलिए बोल रहा हूँ लिखने. Pi is VDC into ADC. तो कैसे आया वो देख लो. I am not discussing that. Then reactive power input QI. Reactive power input. See, active and reactive में फर्क क्या है? देखो इधर. It is V in RMS In of 1 into cos of alpha by 2. Reactive में same है, only sign है. Cos की जगह sign है. So it is sin of alpha by 2. So write down the final formula and the first one. V in RMS In of 1 into sin alpha by 2. And write down it is Vm upon pi I naught sin alpha. This is the last. After it is directly numerical. Qi is Vm upon pi I naught sin alpha. Completed? Write down quickly. So write down numerical, a single phase semi-converter is connected to a 230 volts 50 hertz source. It's written on the board, the numerical statement. A single phase semi-converter connected to a 230 volt 50 hertz source is feeding a load R equal to 10 ohm in series with a large inductance, is feeding a load R equal to 10 ohms in series with a large inductance that makes the load current ripple free. That makes the load current ripple free. For a firing angle of 45 degrees, calculate input and output performance parameters of this converter. Those who are not writing, please write. For a firing angle of 45 degrees, calculate input and output performance parameters of this converter. Acha, tell me which semi-converter it is. It is semi-converter with RL load, or what they have written over there, which makes the load current ripple free. Matlab, what is the meaning of this? Normally load current we have assumed it like this, right? Correct? वो क्या बोल रहे हैं, ये भी नहीं है. It is like this. Our load current is constant. So this is what you mean by ripple free. This is what they meant. ठीक है? But load current constant है. Straight away they are telling that. Okay? Now, ये कैसे करोगे? What's the sequence to follow? If they give you calculate input and output performance parameters, we have to first calculate V out average, I out average, followed by V out RMS, then calculate I out RMS, which will be same as I out average. Why? Because ये constant है. तो अगर ripples ही नहीं है, तो RMS value किसका calculate करने का? Then you calculate PDC, PAC, eta rectification efficiency, form factor, voltage ripple factor, then current ripple factor, In of 1 which is a fundamental component of input. Then phi 1, which is a displacement fact, I mean displacement angle. DF is displacement factor. CDF, harmonic factor. PI and QI. Let's start. Calculate V out average, or call it VDC. So for a semi converter, it's Vm upon pi 1 plus cos alpha. Please calculate and let me know what's the answer. What? नहीं नहीं चलिए क्या देखना है तुम्हें क्या what what please speed up your work a little please. Is it 176.75? Next, calculate I out average. Now answer me this, if it is a RL load, so why when calculating I out average L is not considered? L क्यों नहीं होता? And the value of L is very large. So current flowing to the inductor is almost a constant. Voltage across the inductor क्या होता है? L di by dt. If I is a constant, di by dt will be 0. So VL is 0. That's why we don't consider. If L is, समझा तुम्हें क्या बोला मैंने? Current flowing to the load is constant, right? So that means what? DL will be L di by dt. L is very large and I is constant. What is the constant of a derivative? 0, right? L is 0. Or average energy stored across the inductor is also a constant. So is I out average coming out to be 17 point something? Yes? Now V out RMS. It's Vm into pi minus alpha upon 2 pi plus sine 2 alpha upon 4 pi upon 4 pi raised to half. And what is Vm? 230 root 2. Remember V in RMS is 230. So Vm will be 230 root 2. And alpha you substitute over here as, how will you convert 45 degrees into radians? Multiply by pi by 180. So it is pi by 4. So please verify if the value of V out RMS is 219.3. We can ask you a numerical in the exam only to file up till here for 5 marks. That is possible, right? Calculate average output voltage, average RMS output voltage and average current. That's it for 5 marks. Why not? So you should be ready with everything. Please calculate. What is sine 90? 1. Is it coming to 19? नहीं करो. अगर एक मिस्टेक किया तो all the other things will be wrong. That's why you cannot make a mistake over here. Mostly एक clue देता हो, RMS value normally always higher than the average value. So average value कितना है? 176. So RMS value will always be greater than that. For semi-converters, हाँ? ठीक है? Fine. So we'll proceed from here. As the load current is ripple free, the RMS value of the load current is same as the average value. So I out RMS is 17.675 amperes. देखो I out RMS is equal to I out average equal to 17.675. So from here, what do you calculate? PDC. What is PDC? VDC into IDC. What is VDC? V out average. So calculate PDC, then calculate PAC, V out average into I out RMS, V out RMS into I out RMS, and then calculate rectification efficiency. PDC into 100 upon PAC. Please calculate these three things. I'll give you a minute. Don't just directly write down the answer, please verify them. This is a solved numerical given in PS Vimra. I've taken from there only. As it is, all the values are matching. PDC is coming out to be 3124 watts. PAC it will be V out RMS into I out RMS. अभी rectification efficiency का clue क्या दूँ? It should be less than 100%. अगर greater than 100% आ रहा है तो मतलब you are making a blunder. अगर बहुत कम आ रहा है less than 50% or so, again you are making a blunder because it's a semi converter, full wave bridge rectifier का efficiency you know ना, for diode it's greater than 50%. So is the rectification efficiency coming 80%? 80.6 nearby? Yes, no? Yeah, 80.59 is same as 80.6. Next, calculate form factor. What is the formula for form factor? So you have both the values, calculate. Yes. Remember the basic definition, not the result. All of you completed rectification efficiency. Can I move down? Calculate V out RMS upon VDC. Form factor will come greater than 1. Most of the cases. It's 1.24 coming. Please check. Then calculate voltage ripple factor. It's form factor square minus 1 raised to half. Form factor square minus 1 raised to half. That is 0.734. Coming? इसका मतलब क्या है? 73.4% is the ripple and the remaining is almost continuous. Ripple factor, voltage ripple factor. Current ripple factor is 0. Why? Current में ripple ही नहीं है, it's ripple free, right? So current ripple factor is 0. CRF is 0. Then मैंने क्या बोला था? IN of 1 लिखवाया है ना ये सब. Calculate fundamental value, RMS value of the fundamental current. IN of 1 is 2 root 2 I out average upon pi into cos alpha by 2. IN of 1. Calculate IN of 1. Fundamental current RMS value. Now you know all where all these formulas are coming from, right? So you have the background. Similar thing we have done in full converters also, which probably most of you might have missed. But remember, full converter ka analysis was even simpler than this. Semi converter is slightly, little extra. You can go wrong in semi converter if you don't remember plus one or something. You missed out. Is it IN of 1 is 14.7 amperes? यहाँ पे in power electronics all the currents are in amperes. अगर कुछ माइक्रो में मिल रहा है, मिली एम्पियर्स में मिल रहा है, तो रॉन्ग है वो स्ट्रेट अवे. डिस्प्लेसमेंट एंगल पाई 1 इज माइनस अल्फा बाई 2. अल्फा क्या है 45, सो उसका हाफ. कैलकुलेटर्स को ट्रबल मत करो इसके लिए. देन डिस्प्लेसमेंट फैक्टर इज कॉस अल्फा बाई 2. अभी कैलकुलेटर्स को ट्रबल करो. You don't trouble your brain in this. Cos of 45 by 2. What is cos 0? 1. What is cos 90? 0. So cos 22.5 will be less than 1. So 0.9238. Is it same? ये तो आना ही चाहिए सबको सेम. Completed. Next, CDF, current distortion factor. वो जो खराब शेप वेव शेप मिल रहा है ना, अजीब सा शेप, containing harmonics. What is the distortion factor? We calculate that. That is IN of 1 divided by IN RMS. मतलब इसके लिए IN RMS calculate करना पड़ेगा. So calculate this blue color I have done over here, IN RMS. What is IN RMS formula? IDC into pi minus alpha upon pi raised to half. So quickly calculate that. IN RMS. Current distortion factor. First calculate IN RMS, which should come out to be 15.3 amperes. Is it coming? And then IN of 1 we have calculated 14.7. So their division will be 0.96. Coming. RD's values the same as you are also getting with your calculator. IN RMS 15.3, CDF 0.96. Be smart in your exams, huh? We can give you, see, I give you a simple example. We can give you in the exam the fundamental current value, that is IN of 1, is 14.7 amperes. And the total input current RMS value is 15.3. Calculate current distortion factor. तुम्हें पता होना चाहिए, remember the basic formula. Calculate power factor if displacement factor is 0.92. बराबर है? ऐसा नहीं है कि यही न्यूमेरिकल आएगा, इसके वर्जन्स भी आ सकते हैं. So you should be aware of the basic formula. Basic formula mat bolo. Don't try to remember entire final result. Then calculate input power factor, which is CDF into DF, which you have calculated earlier. 0.96 into 0.9238. Then calculate harmonic factor. Power factor is CDF into DF, which is coming out to be 0.88. Completed. And harmonic factor is 1 upon CDF square minus 1 raised to half. What should be ideal power factor? 1. Anything greater than 1 is wrong. When power factors are always less than 1. So that's your clue कि ये correct है क्या नहीं. Is that fine? Harmonic factor, is it coming 0.2916 or 0.29? Please calculate. 0.29, right? Then active input power. What's the formula? VDC into IDC. Actually ये calculate किया हुआ है पहले. This is same as your PDC. In this case, PI is same as your PDC. In this case, full converter में नहीं है ऐसे. Harmonic factor 0.29. What is PI? We have calculated it before. Just check the value of PDC. It's 3124 watts. 3124. And last, calculate QI. Reactive input power. Remember the unit of active power, watts. Unit of apparent power, VA, volt ampere. And unit of reactive power, VAR. Absolutely correct. The final result same other than that, then let me. हाँ इसमें साइन अल्फा ही है सॉरी. नहीं नहीं ये साइन अल्फा ही है. भाई यू नो बेसिक डेफिनेशन क्या है उसका? वी इन आर एम एस साइन ऑफ वन इंटू साइन अल्फा बाई टू. देखा है वो साइन अल्फा आ रहा है एंड में. देखना है तुम्हें वापस देखना. उससे अच्छी बात है मन में लगा ली बात की बेसिक फॉर्मूला ही रिमेंबर करना है. तो उसकी वजह से भी प्रॉब्लम हो रहा है थोड़ा. बट करेक्ट, इट इज द करेक्ट अप्रोच. Is it coming out to be 1294? VAR, right? Correct. So देखो, you're calculating now. Let me go back to the numerical. Numerical में दिया क्या है? What is the given information? V in RMS खाली बताया सेमी कन्वर्टर है और R का वैल्यू दिया है, अल्फा का वैल्यू दिया है. And so many parameters, so much of information we got. ये इसको ही बोलते हैं एनालिसिस. अगर इसमें मैं डिफरेंट कैसे बना दूंगा? R को 15 10 की जगह 15 कर दूंगा. अल्फा को 45 की जगह 30 कर दूंगा. हो गया डिफरेंट न्यूमेरिकल. करते बैठो मिनट. It's easy for me to change the question, not easy for you all to write. दो वैल्यूज ही है, अल्फा, वी इन आरएमएस एंड आर. दैट्स इट. रेस्ट एवरीथिंग इज सेम. अब इसको फुल कन्वर्टर बना दूंगा. Are you getting it? What I'm trying to say? Given information is almost nothing. Semi converter है, अल्फा है, and R value है. That's it. Rest everything करते रहो calculate. Okay? Numerical. Don't write down the numerical. We are saving some time. I'll explain this numerical and then leave. Now don't write anything. Exceeded time, but today I want to finish the topic of all the numericals which can be asked in this module number 2. At least as for your upcoming exams. So ये क्या बोल रहा है? We have a single phase full converter. RLE values are given. V in RMS is given. And they are saying continuous conduction. They are saying find the average value of load current for a firing angle delay of 50 degrees. Part A है. So let's do that. तो क्या है? V in RMS is given, RLE is given, alpha is given. So what's the formula? V out average 2 Vm by pi cos alpha. Full convert. Go and check it. This is the formula. V in RMS into root 2. So 2 root 2 into 230 divided by pi into cos 50. You'll get the value of average value of output voltage. Now, average value of output current, here where many people go wrong. ये RLE लोड है, L का फर्क नहीं पड़ता, L नहीं आता है, but E है ना. So when there is RLE, this is what I wanted to tell you. Whenever current flows to this, कुछ नहीं हो रहा है. क्यों जीरो है? बिकॉज वो पास कर रहा है एनर्जी, इट्स सप्लाइंग द एनर्जी एंड देन इज रिलीजिंग द एनर्जी. एवरेज तो क्या है ना. एंड ऑफ कोर्स what is IR? IR only. Current also battery. When we say current flows through this battery, we are charging the battery. How do you charge your mobile phone? By connecting the unit, right? Connecting a charger. So it's charging. Current flows through your battery. That means it charges the battery. So whenever we place a battery E in a RLE load, it's charging actually. Right? So what's the result over here? To calculate voltage. We are plus total VR plus E. That's what we have written. So I out निकालना है. So minus E upon R. Just write V out upon R. But since E is also there, that also will be there into picture. So it is V out minus E upon R. Will you remember this? For RLE load. RL load हुआ तो क्या होगा? V out upon R. ठीक है? Now, second question is very tricky. See what they are saying. देखो, full converter में चार हमारे ये होते हैं. I'll explain from here. What they are saying is, in a full converter, out of these 4 SCRs, one is damaged. वो डैमेज हो गया और वो ओपन सर्किट हो गया. वन विच डैमेज है मार्क है येलो कलर. वो बोल रहे हैं इफ दिस इज द सिचुएशन, recalculate I out average, recalculate I out V out average. Assume that this is damaged. हो सकता है ना, ओपन सर्किट हो सकता है. So T3 है ही नहीं, ओपन सर्किट है. Now calculate your I out average, V out average. तो हमें क्या करना पड़ेगा? We have to go back to basics and conductor working. फटाफट वेवफॉर्म बनानी पड़ेगी इसकी, right? So over here we have drawn this. We know this everything together, right? But फर्क क्या है देखो. I'll tell you quickly. 0 to alpha तक कोई ट्रांजिस्टर कोई भी नहीं है. So your output voltage will be 0. ठीक है? Now as soon as the trigger comes, 1 and 2 बराबर चल रहे हैं. So in the positive half cycle, as soon as the trigger comes, 1 and 2 are on, and output will be equal to input. Output will follow the input like this. ठीक है? Now from pi to pi plus alpha, your transistor, your SCRs 1 and 2 will keep on conducting. Right? Because of the inductor. Inductor will tell them to continue further. So from pi to pi plus alpha, your output will be equal to input. उसके बाद क्या हो रहा है देखो. उसके बाद what happens? We go into negative. Pi plus alpha के बाद your T3 and T4 are triggered together. But T3 तो काम ही नहीं कर रहा है. Only T4 is triggering. What will be my output voltage? दोनों ऑन होने चाहिए. अगर एक ओपन सर्किट है, मैं करंट नहीं, करंट विल बी जीरो. अगर करंट जीरो है तो माय आउटपुट वोल्टेज विल बी जीरो. आर यू फॉलोइंग? सो दिस इज व्हाट विल हैपन. ये एंटायर साइकिल के लिए नॉर्मली क्या होता था? वी हैव ड्रॉन लाइक दिस, राइट? बट सिंस इट वाज डैमेज्ड, वी आर गेटिंग द वेवफॉर्म लाइक दिस. आर यू फॉलोइंग? T3 T4 कंडक्ट नहीं कर रहे हैं. इवन इफ T4 इज कंडक्टिंग, T3 इज डैमेज्ड. तो हमें क्या करना है? इसके लिए हमारे को V out एवरेज निकालना है. ओके, so calculate V out average and this is the formula we are getting. ये न्यू है, ये सिखाया नहीं था. This is the situation they are giving. So it is Vm upon pi cos alpha. So with this new formula, you recalculate V out average and I out average. समझ में आया? What is this? It is a solved numerical again from PS Bimra book. It's an unsolved numerical also. Similar case. तो इससे क्या सीखने मिलता है? when all the SCRs were working, what was the current? 12 ampere. अगर एक SCR damage हो गया, how much is the current? Now 1 ampere. The current flowing through the load is severely damaged if one SCR is also damaged. ठीक है, ये जो है सेमी कन्वर्टर का न्यूमेरिकल है. वी हैवंट सॉल्व्ड द न्यूमेरिकल ऑन सेमी कन्वर्टर. व्हाट्स द डिफरेंस? द फॉर्मूला इज डिफरेंट. सो व्हाट दे आर सेइंग, RLE लोड है एंड दे आर सेइंग लार्ज इंडक्टेंस वैल्यू है which will make the load current constant, and alpha is given. You have to determine what? Average output voltage and current, input power factor, and the circuit turn off time. So for a single phase semi converter with RLE load, what is the formula for V out average? Vm upon pi 1 plus cos alpha. You can easily calculate it. What is the I out average? RLE load hai, so it's V out minus E upon R. Again same formula, right? It's not V out upon R. Then load current is constant, so my RMS value of the load current is same as average value. What will be the power delivered to the load? Power delivered hai, what will be power delivered to the load? Power delivered by the inductor will be almost zero. Only battery, मैंने समझाया था ना, बैटरी चार्ज होता है, so it's I out into E and I square R. Power dissipated across the resistor I square R, and across the battery it's I out into E. So calculate this. Then we have to calculate apparent input power. What is apparent input power? V in RMS, I in RMS into cos alpha. We know the formula of I in of RMS, right? सीखा है ना semi converter के लिए. So calculate that. Then you calculate V in RMS is given 230. And what is cos alpha? Cos phi? Phi is minus alpha by 2, right? You have determined that. So calculate this, divide them, you will get input power factor, which will be less than 1. And circuit turn off time is straightforward, pi minus alpha upon omega. Okay, so some numericals are given for home assignment. They are different. No numerical is same. Only this one is same. देखो ये numerical देखो कौन सा है? Which we have solved. इसमें detail में बोला ये निकालो. Just information what is given, alpha is given. मैंने यही बोला था ना, वहां पे R 10 था, यहाँ पे 15 है, अल्फा 45 था, यहाँ पे 30 है, और सेमी कन्वर्टर की जगह फुल कन्वर्टर दे दिया. Input is numerical is same. Similarly, another asymmetric semi converter. What's the difference between symmetric and asymmetric? Everything is same, formulas are same, only the average current flowing through the SCRs are little different through both of them. Rest everything is same. So these are all the numericals which can be covered in module number 2 for your upcoming exams. So next time we meet, we'll be starting with 3-phase full converter with R load and 3-phase semi converter with R load, which will complete in one lecture. So that's all for today. Thank you everyone.